Hello, and thank you for joining us. I am Jasmine Navarez, Digital Content Coordinator at Simulations Plus. I'll be hosting today's webinar behind the scenes, making sure we don't have any technical difficulties. In this webinar, Scientific Product Specialist August Khan and Principal Scientific Product Manager Priyata Kalra will cover how the new Orchestrator tool available on the recently released GPX.2 can help you design and automate complex workflows without having to rebuild them each time. Business Development Director Tom Sanderson will serve as our moderator today. A few housekeeping items before we begin. We take your privacy rights seriously by registering for and attending this event or participating in the Q&A session. You are allowing us to contact you for follow-up. You may ask questions via the questions panel on your dashboard at any time. If you need assistance, please use the hand raise icon. We'll address all the questions in the Q&A after the presentation. And I'll go ahead and pass it over to Tom to introduce our speakers.
Thank you, Jasmine. So starting with August. August has a B.Pharm degree from the Istanbul University and a master's degree from the University of Southern California with a Fulbright scholarship. He's a scientific product specialist in our product enablement team. He joins SLP earlier this year and contributes to the development of GastroPlus by testing and validating new features. And his current focus is on GPX Orchestrator. Priyata earned her PhD from the University of Heidelberg, Germany, with Bayer Pharmaceuticals, developing QSP models for biologics. She then gained industry experience by spanning computational work at BASF and then a hybrid AI PBPK plant model at Bayer Crop Science. She's now a principal product manager for AI solutions and automation at Simulations Plus, where she owns the integration of artificial intelligence across the scientific software portfolio. She also serves as a PBPK expert on the EPAA NAMS designathon, and supports the ICCS reader cross collaboration as the principal investigator. With that, I'd like to hand over to them for the presentation. Thank you, everyone.
Thank you, Jasmine, and thank you, Tom, for the introductions. Good morning and good afternoon, everyone. Thank you for joining today's webinar on Orchestrator 10.2, our first major release of the GPX automation layer. While this webinar details specific functionality of Orchestrator, which is available in GastroPlus version 10.2, what we want to emphasize today is that with Orchestrator, we are also positioning GastroPlus as a simulation service that integrates into your computational and data platforms with which many of you are working and collaborating with. For those of you who are thinking about easing your modeling workflows or finding yourself spending time integrating your modeling activities with various tools and stakeholders you work with, the discussion today addresses both the immediate capabilities as well as where we are headed with Orchestrator. In today's agenda, we are going to talk about the pain points that we are solving and why is Orchestrator existing. We will also cover some of the vision of Orchestrator, and further, we are going to discuss about how GastroPlus and is enabled by Orchestrator to fit into your platform strategies. Several of you have already feedbacked us about integrating GastroPlus with your internal platform. This particular release positions us for those conversations. We are going to also show you the Orchestrator 10.2 functionalities and give you certain examples of the workflow through Orchestrator. And further, my colleague, August, is going to then do a deep dive on the workflow of automation using Orchestrator. Let me start with the challenges using only the graphical user interface limited workflow. And I suspect many of you will resonate with it. The graphical user interface or GUI-centric workflows introduce very strong systemic errors as well as inefficiencies in our workflow many times. Let me give you an example. For example, if you're doing a very complex PBPK analysis, we will end up doing a lot of manual parameter tweaks in our project or in our GastroPlus project using the GUI. And that kind of introduces translational errors or sometimes even documentation gaps. which becomes hard to reproduce in situations where we are doing collaborative work with other team members, or even thinking about doing documentation for knowledge transfer, or even sharing this knowledge with other stakeholders. Furthermore, the GUIs are providing very difficult situations when it comes to being able to do version controlling of our modeling workflows. This leads to have limited traceabilities and also creates a backlog in audit tracking. With this one, I think a lot of you will resonate because a lot of our ground truth sources lie within the Excel sheets with which we work. And so loading data manually from our Excel sheets to the GastroPlus GUI is also pretty slow. Furthermore, if you want to do some what-if explorations, like, for example, dose sweeps or parameter sensitivity analysis, all of these become slower because you have to click in multiple areas within the GUI to be able to achieve those workflows. Finally, this is a big one. We all know it. I'm pretty sure, and I've received so many feedbacks from many of our clients, that we end up using GastroPlus as one of the modeling tools in our workflow and further export all the results into Excel, and then use our own favorite environment or our own organizational approved environment to do our visualization or our automation of the story that we want to tell about our drug candidate, either using Excel, using R, Python, MATLAB, Spotfire, and you name it. With this, it makes sure that Orchestrator is going to become basically the paradigm replicator of the GUI of GastroPlus for reproducibility and modularity, but extend it from the GUI to other aspects of automation. What it does is it lets the scientists automate and reproduce their workflows following very strong FAIR principles by directly connecting GastroPlus to R or Python, or using or connecting GastroPlus engine using the API service to their preferred environment of data analytics tools, machine learning tools, or other workflow environments or internal tools. What this actually means in the architectural format is something like this, what that you see here. So the GPX engine is now become a sole standalone tool in itself, which the user can use with multiple formats of interactions. The user can use the graphical user interface, which is actually the GastroPlus GUI with which you work, or the user can also revoke or call the GastroPlus engine using GastroPlus REST API services, with which they can connect their R or Python or any other internal tools to be able to use GastroPlus in their workflows. This enables us as scientists from going from clicking repetitive workflows through the UI into making this a more automated simulation script, which helps us to do a full simulation set, run a full simulation, or helps us do parameter sensitivity analysis or any other repeatable workflow that you can think of far more consistently. Now, when we talk about this kind of a reproducibility situation, the vision of Orchestrator is basically to be able to empower us and you as scientists to automate workflows for doing drug discovery innovation. It revolves around 5 core principles. The first core principle is to allow you to have automated bottom-up modeling, which means we would like Orchestrator to allow you to enable creation and reproduction of the entire GastroPlus PBPK model through executable code. It also takes the core objective of allowing users to have shared script repository, which makes the collaborative working environment far more effective and easier. It allows you to share, having a script which you can share among different colleagues or different teams helps us to be able to reuse also certain scripts in similar workflow, but for another drug, and helps us have version controls across the different projects. It has a very, very strong value in our entire modeling project workflow. The third is it allows the third vision is to extend integration capabilities of GastroPlus. We would want you to connect GastroPlus with any external algorithm or any external tool that you're going to use. And I'm going to show you an example of this very quickly in the upcoming slides, where, for example, you can use global sensitivity analysis using GastroPlus Orchestrator. You can do the same by integrating GastroPlus with some of your machine learning tools to do hybrid modeling or even optimization workflows to do other complex optimizations for your particular compound. The fourth, as you have also seen and suggested in the poll, is to allow you to do advanced visualization and reporting. This is very important because we are all working in collaborative environments where we have to share constantly our decisions and also the results that we are seeing about our compound to help our stakeholders take the next decision about the compound, whether it goes from discovery to development. And this vision is encompassing that aspect. Finally, the fifth one is to allow for scalable remote execution. We would want to have the capability given to you where you can deploy GPX engine on a high-performance server while triggering and managing the runs securely from your local machine, which is your laptop, and being able to do all the different workflows that you do in your everyday life. So with this, I want to take a moment and talk about the upcoming bigger vision, which is we are enabling GastroPlus to become an API simulation service through Orchestrator. And with this, what we mean is that you would be able to integrate GastroPlus as a computational node within your research and data platform workflows. What this allows is it enables GastroPlus to become a part of effective scale workflows using a platform architecture. In the future, for example, people could do high throughput PBPK for compound triaging as well as high throughput DDI risk assessment in a very quick and a more easy manner because everything is enabled through the same platform. You can also do first in human dose prediction in the future far more effectively, and because of this kind of exposure of the service. Population scenarios with full provenance for MIDD-aligned regulatory submission will also gain a lot of ease when we enable GastroPlus as an API simulation service. Thus, the GastroPlus X.2 is actually a foundation for this tomorrow that we want to enable for all of our users to be able to use the API to do different workflows more effectively. What we offer in Orchestrator X.2 thus is we offer the GastroPlus REST API, which allows easy integration of GastroPlus into various programming languages like that of R, Python, or even any other tool that you feel like using. It also, because of that, it offers you as scientists flexibility to work in preferred environments and also helps increase team collaboration. In the current release, you will see the REST API endpoints as a documentation, which has been delivered to you. You can then decide to deploy it. On the other hand, for direct users, you will have a GastroPlus API package, which has been delivered to you. This package helps people to load, configure, manipulate any simulation of a GastroPlus project using both R and Python. You will also receive a GastroPlus R modulins package, which is specific to R. This particular package is an extension of GastroPlus API package. And what this package does is it helps you perform multiple API calls together using only one function. The idea behind this is that when you will do workflow-related automation, you might need to call multiple aspects of the API calls to collect data or even to do visualization. What GastroPlus R modulins does is it provides you helper functions to wrap some of these API calls into one function so that you don't have to do 3 to 4 calls in one go. Finally, we do provide a lot of scripts in the repository for you to have your automated workflows. In the provisions, you will find a possibility to do automated PSA, possibility to do automated compartmental as well as NCA, how to run a POP SIM. We also have execution of VBE, etc. All of this will help you use the same script or even advance the scripts that we have provided to your particular workflow. And this helps you to minimize your errors, to save your time, and also support some of your high throughput research. Now, when we look at the functionalities of Orchestrator in GastroPlus 2, we kind of divide them into 3 buckets. The first bucket is that of project creation and modification. In this particular bucket, you'll be able to have the different functionalities of being able to read and load observed data automatically. You'd be able to import admit predictor compound into GastroPlus automatically. You will be able to also assess and modify different variables, and you'll be able to reuse multiple model components using different API calls, using the R or Python functions very easily to create or modify a particular project related to your compound. When it comes to the modeling and simulation aspect of the particular compound, you'd be able to configure and execute GPX run modes. For example, the optimization run modes, the PSA run mode, the simulation run mode, etc. You'd be able to do PK plus analysis. You'd also provided the capability of being able to do IVIVC plus analysis. We have also opened another capability through Orchestrator, which is to be able to do global sensitivity analysis using the Morse method from the sensitivity package using in R. Further, you'd be able to do any kind of high throughput PBPK or high throughput PK using for your compound screening using admit predictor port. The third bucket is that of plotting and visualization. As I have already said in the past, that we are providing an extra package which is called GastroPlus R Modulins. This particular package is the package which houses all the plotting and visualization, as well as the helper functions related to being able to do all the visualizations for your particular workflow. It allows you to have quick grabbers for the various API calls. There is a provision of being able to plot the goodness of fit, to do 3D PSA, and also to have spider plots. We also have functions which can help you plot not only CP time curves, but also mass time curves, and also mass concentration curves. And furthermore, we have allowed and enabled a GastroPlus theme to you for being able to create plots very quickly with a consistent theme, if in case you'd like to use one. With this, I'm going to show you how this kind of looks like when it comes to using HTTPK workflow. We can consider to do HTTPK workflow in 2 different environments now. You can do it within the GUI, and you can do it within the Orchestrator. Now, when we do HTTPK workflow, we will start by picking up a project, and then we will import in this project 2 new compound structures, for example. And I'm going to walk you through of how you're going to do this in GUI versus how you're going to do it in the Orchestrator workflow. Within the GUI workflow, you're going to go into the GUI, and then you're going to click on the project location, going to browse where the project is, and then going to open this project. However, within Orchestrator workflow, you're just going to give the project name by passing the relative path of where the project is located. And afterwards, you're going to pass the function open project, and then pass the project name in this open project. Please keep in mind that the functions are similar in both R and Python packages, so there's not a difference in taxonomy of the functions. Once you open the project within the GUI or within the Orchestrator workflow, within the GUI, the way you are going to import these 2 structures is going to be going to the modules, going to the admit predictor module, and then selecting a file of where and locating the file where these two compounds are located. Within the orchestrator workflow, you are again going to just reference where your structure file is located, and then you're going to call the function load structure. With that, it's going to load that structure within the environment. Afterwards, within the GUI, you have to define if you would like to change the dosing schedule or the physiology schedule or the pharmacokinetic model, you're going to go into one of those options and then going to click on the drop-down of the possible dosing schedules or the physiology schedule or the pharmacokinetic model options. Within the orchestrator workflow, you're just going to first get the admit predictor import configurations, assign it to a variable, and once you assign to the variable, then you're just going to call one of the parameters of that particular class, which is, in this case, I want to change the dose schedule to 100 milligram PO tablet, 25 micrometer. In this case, we are going to say that this is dose regimen name, 100 milligram PO tablet, 25 micrometer, and then set admit predictor import configuration to this particular configuration. After that, in the GUI, you're going to click on Start Import. Within the orchestrator workflow, you're going to call this function called import structure. Once you have imported these structures within the GUI, you're going to go to the runs pane and then go into the particular run, which was from the admit predictor imported run. And then you're going to start the particular run to be able to see the run. Within the orchestrator, you're just going to call the run name, which is called run, and then you're going to execute that particular run name. Once you have executed the run within the GUI, you get to see the analysis view, and within the analysis view, you see the CP time curves being plotted. Once you see them, you go into the GUI plus signs over here for the plotting, and then do further editing of your plots to be able to make them ready for your particular visualization. Within Orchestrator, this is where there's a bit more flexibility. You first decide what kind of series you would want to be displayed. This particular series can be built by using the modulins function here, where we are saying that we want to see the concentration plasma found in the systemic circulation for the imported compounds. And once you build that particular series, you can then get all the series associated to the different compounds which were imported for the systemic circulation concentration plasma, and then you're going to plot them. And the plot itself is, as you know, with using R or Python, are for very easy. We have also provided you a plot series data function, which allows you to just pass the series and then plot them with different colors and change the faceting of the different compound simulations. And then you can see the final result of your plot. Another example is going to be that of where you can find the detailed documentation and guidance of GastroPlus. You can go into the GastroPlus SLP softwaresuite.com, and over there in Orchestrator, we have given you full documentation. All the example scripts are also provided over there in the documentation. Besides that, my colleague August is going to show you where else you can find all the shared scripts on your computer. The second example, which is the example of being able to allow the extended integration capabilities of GPX or GPX of GastroPlus using Orchestrator, is that of allowing you to do global parameter sensitivity analysis. In here, the workflow is that the script that we have provided, it executes a global PSC analysis for specified variables, which you see over here. In this case, these are the variables related to the stomach lumen, or we have the small intestine transit time and small intestine length, the solubility of the compound, the particle density of the compound. And then it retrieves the summary results for each of the iterations for the lower and the upper bound that were given for this global sensitivity analysis. And then it applies the Morse method from the sensitivity package in R, and it provides you a sensitivity plot, which you can see here. With this example, this script is with you, so you can also try to modify it for your particular workflow to be able to do global sensitivity analysis. And with this example, I'd like to pass this on to my colleague, Oz, to show his live demo.
Hello everyone, my name is Oğuz Khan and I'm Scientific Product Specialist at Simulations Plus. Today, I will walk you through a short demonstration of how GastroPlus Orchestrator allows us to interact with the GastroPlus simulation engine programmatically through REST APIs. We will see how you can set up your environment in Python and R, open and run projects using the API, and retrieve outputs and visualize results directly in your scripting environment through example scripts. Before diving into demonstrations, let me quickly point out where everything lives in your system. After installing GastroPlus 10.2, the two applications will occur in your desktop, GastroPlus 10.2 and GastroPlus 10.2 Web. GastroPlus 10.2 Web is a way to start the GastroPlus service with a port number manually, so that user has freedom to access and connect to this service to do API calls from their preferred environments. In this demo, we will launch GastroPlus service through R and Python packages, so we will not use this option. So let's move into where Orchestrator components are stored. So I will navigate to File Explorer, this PC, C drive, Program Data, Simulations Plus, GastroPlus Orchestrator, and 10.2. You will find the Python package and R package and set of example scripts in this folder. Example scripts are really helpful starting points to replicate and modify your own workflows. Now, I will proceed to RStudio. Here we have already installed both GastroPlus API and GastroPlus R modules packages previously. I'll navigate to Packages tab and search by Gastro. Here you can see the two packages installed previously. I will navigate to GastroPlus API's documentation. Here we have provided a detailed documentation for all of the functions we support for the 10.2 release. I will click on a functions call here, and we have also provided detailed information how to make that functional call in GastroPlus API with an example here. Let's also quickly take a look at the GastroPlus R modules package. This package is a modular analysis tool for GastroPlus. We provided many useful functions to create quick plots and data handling. Please note that we utilize GastroPlus R modules package in the example scripts and recommend it to use in your own scripts as well. Now, let's open a new R script and take a look at how we can interact with GastroPlus from R. I will start by loading the GastroPlus API library. This package gives us access to the GastroPlus engine directly within R. I will type library, and I will assign the GastroPlus API name inside of it, and I will execute the function. Next, I will establish a connection to the local GPX service, which is the REST API service running in the background. So I will type GPX web service, variable name, and then I will assign the output of the start service function here. Here, I will only assign the verbose argument as a true in order to get the service initiation details, and I will execute this function. See that the service initiation details are provided in the console with the port number, but you do not need to do anything with the port number. The package itself is going to handle everything. Once connected, we can open a GastroPlus project programmatically. Here, I will open a sample project file called demoproject.gp project. So I will use the open project function, and I will assign the project path arguments. Inside of this argument, I need to assign the path for the project. So this project is stored in the documents demo project here. What I'm going to do is I will shift right click on this GP project and I will copy as path. And I will paste the clipboard here. What I need to do here is I need to change the single backslashes to the double backslashes. And then I will execute the function. Now, the project is successfully opened in the service. What I can do with this project is, let me show you a simple function. So get simulations. So when I run this function, it will bring me to the simulation assets in the inventory. So you can see that there is only one simulation in my end right now. Once you are done with GastroPlus, you can terminate the service with GPX web service $kill. Now the service is terminated in the backend. Notice how straightforward this is. No need to use the graphical user interface if you want to automate workflows. So in just few lines of code, we have connected to GastroPlus and loaded a project ready for simulation and further analysis. Let's take a look at one of the example scripts. I will navigate to example scripts folder and open up batch simulations run our markdown file. This script will execute the specified simulation and plot the CP time. These examples are structured as small, self-contained chunks you can run top to bottom. I'll start by loading the packages. We use GastroPlus to talk to GastroPlus service and tidyverse for quick data wrangling and plotting. Next, we set the working directory to wherever this RMD lives, so relative paths work out of the box. Here, we start and connect to the GastroPlus REST service. This block is where you customize a demo for your own studies. We point to project file, specify the simulation name and run name, and also assign the observed data identifiers. Now, we open the project, create a batch simulation run, add our simulations to that run, and execute it, fully programmatically. After the run finishes, this block pulls back the results, such as the simulation keys and summary output from the simulation, which contains the pharmacokinetic parameters. Then we fetch all the concentration series from the simulation results, grab the CP time data, and then also get the observed data details from the inventory. In this plot results chunk, we build a quick concentration time plot with GGplot.2. Overlaying the simulation profile as a line and the observed data points as markers. Here you can see the final graph created by the GGplot.2. This is the concentration in plasma versus time graph for metaparallel tetrate 200 mg PO tablet simulation in the project. To clean up, we stop the local service so it doesn't keep running after the session. That's the pattern all these examples follow. Configure packages, start the service, set your inputs, run, pull results, visualize, and shut down. You can copy this R markdown file, change the project and simulation names, and you have got a repeatable, scriptable workflow. Now, let's move into an automation workflow. Imagine you have a set of drug candidates and you would like to quickly predict the pharmacokinetic parameters in GastroPlus using ADMET Predictor. With Orchestrator, you can automate this process so that multiple compounds are handled in one streamlined run. Here, I have opened the example script, ADMET Predictor import 21 structures to a new project. This example shows how GastroPlus Orchestrator can automatically import a batch of compounds into GastroPlus through ADMET Predictor calculations and execute simulations, all in a single step. And while this particular example uses 21 compounds, the same workflow can easily be scaled to dozens or even hundreds of candidates, making it ideal for high-throughput screening and rapid decision-making in early-stage projects. We start the same way as before, loading the GastroPlus API and helper libraries. This ensures we can talk to GastroPlus service and manage data frames in R. Then, we will set the working directory. Next, we connect to the GastroPlus service and check if the service is alive. Then, we will specify a set of input information, in this case, project path and structure file to be imported. Then we will open the project and get the list of current compound assets before the ADMET Predictor import. See that our project does not contain any compounds, as current compounds variable is null in the global environments. Here, the script loads 21 molecules to the ADMET Predictor module. Then gets the default configuration of the ADMET Predictor. You have ability to change the configuration based on your project purposes. Here, we change the dosing regimen and physiology schedule in the configuration object. Then we set the new configuration, and then we import the structures. Once imported, we can execute the respective simulation. This chunk executes the automatically created run, including all batch simulations from Advent Predictor. Then it retrieves key outputs such as plasma concentration time data, which can be saved or plotted for downstream analysis. The data is stored in series data AP import variable. I will open this variable. See that all CP time data are stored in an organized way here. I will navigate back to script and proceed to next chunk. This chunk plus the data provided in the previous chunk. You have freedom to apply any plotting to the data. Here, we plotted the CP time curve for each compound imported through Advent Predictor. Here is another plotting example that you can compare your compounds based on pharmacokinetic parameters. As you can see, this workflow highlights the high throughput capabilities of GastroPlus Orchestrator. Entire sets of compounds can be imported, analyzed with Advent Predictor, and prepared for simulations, all programmatically within minutes. Since we are done with the GastroPlus service, I will terminate the service with GPX service kill function. With this example, we completed the R side of the GastroPlus Orchestrator. Now we will proceed to the Python part. We have also provided a Python package for the orchestrator, designed with a very similar structure to the R package. This highlights the flexibility of GastroPlus Orchestrator, allowing you to work seamlessly in either R or Python depending on your team's preference. We'll start with the documentation. Navigate to the Orchestrator folder, open the Python folder, and go to documentation. Here you can see a Markdown file called README. With an appropriate Markdown Viewer extension in Microsoft Edge or Google Chrome, you can view and learn details about the Python package. Here I opened up in the Microsoft Edge and we provided detailed information as we did in the R package. Now let's move into coding part in Python. I will open up the VS Code and the new Jupyter Notebook. First, I will load the GastroPlus API library, which we have installed for the Python previously. And then, I will establish connection to the GPX service and configure the GastroPlus client. Once connected, I will open the same demo project with the following code. Notice that how it is similar to the R package. Once you are done with the service, you may terminate the service with GastroPlus service.terminate. Now, let's take a look at batch simulation run example script in Python. I will navigate to GastroPlus Orchestrator folder. I will go to Python, example scripts, and here I will open up the batch simulation run.ipynb. We start by importing the GastroPlus API package and setting up a connection to the local REST service. This works just like in R. By default, it automatically launches the service, but of course, a port number can be assigned by launching service with GastroPlus 10.2 web application as well. Here, I will assign the setup variables related to my project. Then I will open the project and execute the specified simulations through runs. This is nearly identical to what we just saw in R, only the syntax differs. The important part is that the automation logic is the same. Next, I receive the iteration keys and summary outputs. Then I access the all concentration series for this simulation. Then I retrieve the CP time data and observed data. As a final step, I visualize the simulated CP time data. Here you can see the plotted CP time curve for the metoprolol tartrate 200 mg PO tablet simulation. So in just a few short steps, we have replicated the same workflow in Python, opening a project, running a simulation, and retrieving results. The key takeaway is that both R and Python interfaces provide the same power and flexibility, so you can integrate GastroPlus into whichever environment fits for your workflow best. That concludes the demonstration. Thank you for watching, and please don't hesitate to reach out to us if you have any questions.
Thank you, Jasmine. Thank you, August. Thank you, Priyata, for a great presentation. The first question, funnily enough, is one I can answer, which is very rare in these things. But I'll just jump in just to spare August and Priyata from this point of view. The question is, do you have to purchase a separate license for Orchestrator, or is it part of the GastroPlus X.2? And I can confirm it is part of the base GPX.2 package. And I think, as was shown during the presentation, there will be documentation within the installation files and everything else for how to get it working. And with that, I will then pass on to questions for August and Priyata. The first being, in fact, there's two of them that came in, is asking about whether Orchestrator for non-R users, well, in fact, they're related. Is there a tutorial on Python? And also, is there a tutorial for non-R users and how to use it with an Orchestrator?
August just showed a small script for Python. We do have similar scripts for Python. So the scripts themselves are very much step-by-step tutorial. If people follow them, that's the reason why they are written like a markdown. You will find instructions on the top, and then you will find the code chunk in the middle. That was the answer for the Python. What was the second part?
For R.
The same. We do provide these scripts like tutorials. For sure, there's going to be also small tutorials which you will do if you do some of our courses, like the Autumn School. If you have attended, you must have seen how to implement Orchestrator in your Autumn School. But we do not really teach R or Python. We expect users to learn R or Python on their own. At least that's the basic expectation.
Great, thank you. What is the data format required for Excel/CSV files to import data via Orchestrator?
It's a very good question. To be able to import data within Orchestrator, the format is more or less normal format of that of long form. Of course, if the data is not in the long form or is in the wide form, you have R or Python, which can do their own data manipulations. You can use tidyverse to do data manipulations, put the things in long form, and then basically chunk it out in different parts of the way the observed data has to be imported and imported using the for loop. All of those details are also provided in the example scripts with a step-by-step tutorial on how to do it in different formats.
Great. And then does a GPX.2 project need to be fully set up in the GUI before you can automate the services through Orchestrator and apply them?
Thank you for this question. That is very true. This is at the moment, you have to set up the entire project within the GUI and afterwards call it through Orchestrator. In 10.3, all of this will become more programmable. So you'll be able to create, you'll be able to set up everything without needing to go to the GUI at all. For now, you'll have to just execute things once they are set up in the GUI.
Thank you. Is it possible to use the script to do a PSA with any methods, such as Sobel, Morris, or others?
Yes, of course, you can use the scripts to do PSA with any method. We have provided the example of the Morris method, but for example, you could also use the Sobel method by changing this method from the Morris method to Sobel method. There would be requirements of some tweaks for sure from the programming perspective. You can also contact us if you are getting into trouble doing that. We'll be happy to help you.
Great. And funnily enough, another question that I can answer is when GPX.2 and Orchestrator will be available to existing GPX users. Well, the new version has been released as of about 2 weeks ago or so, or a couple of weeks ago. And if you're not using it yourself, then a member of our team will be working with some of your colleagues, maybe in the IT departments, etc., to help get set up on the transition. So it is released now, and certainly reach out to the contacts that you have at Simulations Plus to learn more. Another question has come in, which may not be as applicable to this conversation about Orchestrator, but I'd like to ask it because it actually might be applicable to many users who sort of work in similar programs. Is someone is developing a PBPK model for drug metabolized by the AADC enzyme, and they're unable to find the required kinetic parameters such as Vmax, Km, etc. for that enzyme, either within GastroPlus database or in the literature. And should they use the optimization module to determine such parameters for AADC?
Nice question. Yeah, in this case, the first thing that the user would need to do is they would need to set up a custom enzyme, of course, because it can't find it inside the GastroPlus expression of the enzymes. They need to add the expression in the gut or in the tissue, depending on where this enzyme has been expressed and if they have this information. And later on, if they do not find any Vmax or Km expression or expression-related details, for sure, they need to use the optimization module to do that.
Thank you, Priyata. Sorry, just checking through the questions. For an automated batch upload with the script, can they mix with ADMET predictor parameters with observed values?
Very much. So when you do the automated workflow, it is very much similar to what you would do on the GUI. If you are also mixing sometimes ADMET predictor with observed values, it's possible to do that. One more thing is one thing that you don't need to worry about setting up already in your project or GastroPlus project is the upload of data. This can be very much handled directly through Orchestrator, and also to do any kind of AP related activity. Any kind of ADMET predictor activity is more or less standalone handled by Orchestrator at the moment. Not all of it, but huge parts of it.
Right. Some more coming in. What level of control does the API provide for customizing simulation parameters or outputs?
As far as I know, there's a huge customization allowed for simulation parameters and outputs. We have exposed almost all parameters, right, August?
Sorry, not all the parameters, but like the main major parameters like solubility, dose strength, permeability, I don't know, like some RBP, FUP parameters, like the major parameters in the GastroPlus, the majority of them we have exposed, but like some minor parameters, like solubility of the form 1, form 2 polymorphism, and other small details like tissue compartment details. Those are not able to editable right now, but those will be provided in the next release, which is the 10.3.
Great. What are some common use cases or quick wins that teams have achieved with Orchestrator so far?
Well, I'll let August answer that. He has some.
So far, basically, we have received a request from one of our clients. Basically, they were looking for some partial pharmacokinetic parameters. Basically, they were running a PubSim, but they wanted to only get the last administration pharmacokinetic details. But in GastroPlus GUI, you're not able to do that. But in the Orchestrator, basically, you can just simply grab the data, simulate it. You can simply execute the simulation in the Orchestrator, grab the data from the GastroPlus, crop the data, and then do some pharmacokinetic analysis on that data, and easily you can get those details. So it was one of the quick wins that we did with the Orchestrator after this short amount after the release time. But there are so many possible things that can be achieved through the Orchestrator. This is just one example.
Right. And just realizing the time, and obviously people are going on to other meetings and everything else. So time for probably one last question. And if we don't get to every question that's coming in, we'll obviously get back to you directly. This is related in part probably to some of the tutorial questions, but it's worth just mentioning again, is how much scripting knowledge is needed to automate routine workflows, and can a non-programmer set up simple tasks?
That's a very good question. So, of course, you need to have some programming language, but in today's time, because you don't have, even if you don't have the programming language, we do have some of our AI helpers, which are more or less allowed as co-pilots from our companies, from Microsoft, for example. You can always ask them questions to help you navigate through writing the script. If that's also not helpful, you know where to reach us at, and we'll always support you with your scripting workflows.
Great. Well, with that, thank you, August, and thank you, Priyata. I'll hand over to Jasmine to wrap up the webinar. Thank you, everyone.
Thank you all. So for any questions, as Tom mentioned, that we were unable to answer live today, someone from our BD team will reach out to you with answers following the webinar. We hope we see you in next week's webinar, where experts will go over the new AI-powered tools available in GastroPlus 10.2. We also invite you to visit our website to learn more about GastroPlus and our other software platforms. I put a couple of links in the chat if you'd like to follow us on social media. This webinar has been recorded for playback and will be available on our website and YouTube channel. This concludes our webinar for today. Thank you, everyone.